Yeah, they're so pretty and yellow. Except for those ones over there.
Yes. Hey, do you know why those plants look so sick?
It looks like a fungal infection. Gross! Maybe we should ask Munmun and Kelly from the Kievit Lab. I hear they work with canola to protect them from getting sick.
Quick.
Oh! There they are. That's convenient.
Can you please explain to all of us what's wrong with that sick plant?
Sure. This plant has been infected by a pathogenic fungus called Sclerotinia sclerotiorum.
Oh no. But can't we use pesticides to control it?
We can, but did you know they have several negative effects?
That's right. They can develop pathogen resistance to the applied agents, and they have non-target environmental impacts.
Also, consumer demand for pesticide-free food has led to a search for substitutes.
All of the healthy plants here are being protected from infection, but it's not because of pesticides. It's being protected by a biocontrol agent.
Like the ones we use in our lab, right?
That's right. We study biocontrol bacteria, which are able to inhibit the fungi from causing disease in plants.
Plus, they don't cause disease in humans, so they represent an environmentally friendly pesticide.
A good example. Another example is one of the bacteria that we work with, Pseudomonas fluoratus strain PA23.
Yes, it produces compounds like perolectrin, penicillin, HCN,
Proteases
and
lipases. It's these products that inhibit sclerotinia skin rot and blackhead disease.
That's right, we know this through studies we have done in our lab.
But why do we care how this bacteria is able to do this?
Because if we can identify the genes responsible, we can optimize the bacteria produced in the field.
So, how can we make PA23 more effective in the field?
Well, one example is that our lab has found that perolectrin is the primary antibiotic responsible. For killing off the sclerotinia fungus. We need to understand the genes responsible for producing these compounds. In PA23, this is controlled by the balanced expression of lots of genes. And if we mutate one of these genes, we lose biocontrol activity in PA23.
But how do we identify other important genes in the chain?
Through random mutations of the genome, we've identified another important gene called PTRA that also causes PA23 to lose biocontrol activity when it's mutated. Right now, I'm trying to figure out what its role is in controlling biocontrol activity.
That sounds really important. By the way, Kelly, what do we know about how PA23 affects the canola plants?
Great question. We suspect that PA23 actually helps canola defend itself against infections by turning on its immune system. Lots of bacteria are able to do this in different plants, and it's called induced systemic resistance.
Is there a way to check this out?
We can spray canola with PA23 and then check the expression of defense-related genes in the plant. Right now, I'm trying out a really cool experiment. We can actually see how spraying the plant with PA23 affects the stomata on the leaf. Stomata are like breathing holes on plant leaves. They allow for gas exchange. We can use microscopes on live leaves to see how the stomata react to PA23.
That's really neat.
So, Munmun, do the biocontrol bacteria have the risk of predation?
Yes, they do. Bacteria that live in the soil can become a meal for bacterial feeders like nematodes and protozoa. For example, disease of free-living bacterial nematode called Cenorhabditis elegans.
Oh no! Do they have a means of protecting themselves?
Yes, some of the products they release can either kill or repel the predators.
But bacteria are so tiny. How will they survive predation by the nematodes?
Okay, try to think of it this way. In order to produce biocontrol compounds, a lot of energy is required. So these compounds are expected to offer a fitness advantage to the producer in its natural environment.
Aha! That means bacteria have evolved anti-predatory resistance mechanisms.
Yeah, such as producing unpalatable compounds or toxic metabolites.
Unpalatable? Like broccoli?
That's right. Or poison for the nematodes. Like this trick. It can produce
Click. Click.
So how can we know whether PA23 affects the survival of these nematodes?
That can be determined by performing specific assays. That
have to
is
click.
determined by performing specific assays while treating the nematodes, either the wild type or one of the several mutants deficient in production of one or more biocontrol compounds.
Gotcha. I think we can also use microscopes to see if there's any pathological effect, right?
Yes. And of course, we need that to observe symptoms associated with feeding the nematodes bacteria attacked with fluorescent proteins.
No.
See, nematodes feeding on PA23 can get infections like this. Click.
More clicks! More clicks! Yay! Infections like this. Wait a minute! Disintegrating codads! Ouch! But the nematodes can interfere with the production of biocontrol compounds, right?
For sure, in that case, we can use several methods to analyze the expression and biocontrol compound formation by the bacteria in the presence of nematodes.
I guess we're both working towards making PA23 an effective biocontrol agent.
Right? So we should not forget these little creatures, which are a great alternative to pesticides.
Yay! Thanks, you guys. We learned so much.
Ivan said we could, oh, that's a better shot. Sorry. Ivan said we could put it on the Facebook page too for micro. Because I think you have a better view than I do with the back window.
Yeah,
so
I
that's
can do that. Yeah, no problems.